Okay, for those of you catching the recording, I'm sorry I started early and I forgot to record, but all we've done so far is talk about the triangle inequality theorem. The sum of the lengths of any two sides of a triangle must be greater than the length of the third side. So again, if you're joining the recording, I just did a visual demonstration with 3 items: this green fertilizer stick, a cap, and a pencil to show that I can make a triangle if I have segments of 4, 3, and 8. And what Ava just helped me show is that 3 plus 4 is 7, and 7 is not greater than 8. It's not greater than 8. So that's not a true statement. This is not a triangle. There's no way to form a triangle with sides that are 4, 3, and 8. Okay, now that we're all caught up, or for anyone in class who fell asleep while I was teaching that earlier, now we're all together. Now we're going to do some examples. So I've got 3 side lengths, 4 problems, and we're going to decide, is it possible to draw a triangle with the sides of the given measures? Okay. Now we have to try all of them. So I'm going to try 15 plus 12 is greater than 9. I'm going to see if that's true. I'm also going to do 12 plus 9 is greater than 15 and see if that's true. And I'm going to do 9 plus 15 is greater than 12 and see if that's true. Now, the more we do, you might notice some patterns and be able to not do all 3. As soon as you get 1 no, you're done. But just to begin with, since we haven't done this yet, I want to try all of the combinations of all the sides all together to make sure they all work. Now, what I'm about to do in pink, you don't necessarily have to do, but this is what I want you thinking. So we're thinking 15 plus 12 is 27. Is 27 greater than 9? Yes, that's good. That's true. That's a true statement. Now I'm going to do 12 plus 9 is greater than 15. 12 plus 9 is 21. 21 is greater than 15. Oh, that's true. Yep, keep going. 9 plus 15 is 24. 24 greater than 12. Oh, also true. Perfect. When all 3 of those, any way you can mix, match, slice, dice it, it works. I can say, yes, that's a triangle. These 3 sides will make a triangle.
So it has to be like true for each one?
Mm-hmm.
Okay.
And so what we're about to find is if you have one that doesn't work, you can just stop there. So let's do number 2 together. 23, 7, and 16. Okay, let's try 23 plus 7 is greater than 16. 23 plus 7 is 30. Is 30 greater than 16? Yes. Also, I'm going to just let you know, as we do more of these, you know that 23 is bigger than 16. So adding 7 to it will keep it bigger than 16. So some of these you won't physically have to do. You can reason your way through it. But I'm teaching you this as if you didn't reason or you weren't going to reason your way through it. So even if you didn't reason your way through it, we should be able to know that they add together. And then now I'm going to move it over and do 7 and 16. Is that greater than 23? Well, 7 plus 16, oh, that's 23. Is 23 greater than 23?
No, it's equal.
Equal. So it can't be greater than. That's not true. No. The minute I get this not true one, I'm done. I'm not checking anything else. I'm going to say there's no way. This is not a triangle. Okay? Why don't you take a minute and you try the next 2? Try these 2 over here. I'm going to leave this up if you need to check it. Take a minute, try the next one. All right, take another minute. All right, let's look at number 3. Who can help me on number 3?
I can.
All right, help me out, Ava.
So right away I can see that 10 plus 9 is not greater than 20. So that would be no.
Good. 10 plus 9 is 19, and 19 is not greater than 20. So you don't have to do anything else. That's not a triangle. Very good. All right, somebody new, help me on number 4.
I can.
Awesome, Gwenna.
Well, this one I already knew that anything added to 28 is going to be more than 28. So I just wrote down 28 plus 28 is greater than 28.
Perfect. And you knew without doing any math, if I add anything to just even one of these 28s, it should be bigger and it should be enough. That was a true statement. And so we're going to say, yes, this can be a triangle. Does anyone know what kind of triangle this would be?
Equilateral.
Isosceles?
Isosceles is the big umbrella, so that's true. Most specifically, it is equilateral. Both of those statements are true. And so equilateral, I don't think I spelled any of that right. Whatever. We know it's an equilateral. And someone in my other class said, well, if we know an equilateral triangle is okay, we're allowed to have all the sides be the same. I didn't have to check my math because I knew this was okay to be for a triangle. And I said, okay, that works. If you know an equilateral triangle is all the sides are the same and all my sides are the same here, then that makes a triangle and we don't have to check it. That's fine. Any questions so far? Okay, so again, the big umbrella idea was that 2 of the sides have to be summed to be greater than the 3rd side. So in this next set of problems, we are missing the 3rd side. We're missing one of the sides of my triangle. I have 7 and I have 11, and I want to know between what 2 numbers should that 3rd side be. Now, we don't know which side we're missing. Remember, I had these 3 objects before, a cap, a stick, and a pencil. I don't know which of these 3 I don't have. So I have to consider all of my options. I could be missing the smallest side, so I'd have X, 7, and 11 if I ordered them, numerically. I could also have it be the middle side. X is in between 7 and 11. Or I could be missing the longest side. 7 and 11 might be the 2 short sides, and X might be the longest side. So we have to consider all of that. All right, I'm going to show you work that we are using from our knowledge of the triangle inequality theorem, but I'm going to show you a shortcut in a minute. I like to make us work to get to our shortcuts, just so we understand how we got there. So we have to check our triangle inequality theorem in a couple different ways. So first, I'm going to check and see if X is the smallest side. So I'm adding the 2 small sides to see if they're greater than 11, the 3rd side. X plus 7 is greater than 11. We minus 7, and we got X is greater than 4. So X must be bigger than 4 in order for X to be the smallest side. So 4 is the smallest we can go. The next one we did is where X was in the middle, and so we did X plus 11 is greater than 7. Well, when I minus 11, I got negative 4. Well, obviously a side has to be bigger than negative. I can't have a negative length of a side. It has to be positive in order to be a side of a triangle. So that is not a helpful one. We don't ever have to do that one again now that we showed that that wasn't helpful. Now my last pair is if I do 7 and 11 are the 2 smallest sides and see if they are greater than X, the biggest side. In that one, I add X plus 7 together and I get 18, and 18 is greater than X. So we crossed off that middle one, but the 2 on the outside are true. X must be greater than 4, but 18 is bigger than X. Let's draw that on a number line. So my numbers are 4 and 18. X must be greater than 4, but X must be smaller than 18. So I'm looking at all of the space in between them. Now, when we draw on a number line, we always use open or closed circles. Which one am I going to use here?
Open.
Why?
Because the closed circles are like greater than or less than or equal to, and we don't have that.
We don't have any or equal to, right? We just have greater thans or we just have less than. So we're going to use an open circle. 4 doesn't count. 18 doesn't count. We can't have those side lengths. If you remember from this problem up here, I said, is 23 greater than 23? No. So we could not have had these sides where the sum is equal to the other side. That's not okay. That's a problem. So we use our open circles. And we're going to write this as an inequality. So we're going to say 4 is less than x, which is less than 18. So every time I give us a problem like this type of problem is going to be an interval. I'm looking for not just one numbers, but I'm looking for like a range of numbers from one to another. And our answer will be in an inequality. So sometimes it's just helpful to know like what kind of answer am I giving? Is it just one number? Is it a group of numbers? Like what is it? And this will be an inequality, which tells me like a range of numbers from this one to this one. What have I got? Okay, now let's talk about the shortcut. The shortcut is that the number that it's the smallest number it has to be bigger than is the difference of the two sides that we have. We know that my sides are 7 and 11, so the difference of 11 minus 7 is 4. And actually, we just did that a minute ago in that first box. We set up an equation to get there, but the shortcut is simply just the difference, 11 minus 7. The bigger number, the number that we have to be smaller than, comes from the sum of those numbers. 11 plus 7 is 18. And that's what we did in the last box. Again, we set up a nice pretty equation, but basically all we did was we added the two numbers, the sides that we already had, together. And so the shortcut to find this is if I ask you for the measure of the third side and it's between what two numbers, we're going to do the difference of the numbers that we have and the sum of the numbers we have and write my inequality. So for example, I'm going to go do this first one right here, 9 and 15. We're going to do the difference. We're going to do the sum. My difference will be 15 minus 9, which is 6. I knew to write 15 first and not 9 because 15 is positive and I don't want my side to be negative. We already said that it doesn't make sense for a side to be negative, so we don't want that. My sum now, it doesn't matter what order you put it in because addition is commutative, and that's 24. 15 plus 9 is 24. So I've got 6 is less than x, which is less than 24. Okay. I want you to try the next two. I'm going to need help from people I haven't talked to yet. So if this is something you want to help me with, think about that. Be ready in a minute. Think about that. All right, take a minute to finish up. All right, someone I haven't spoken to yet. What's my range?
I'll do this one.
Okay, Ben's ready. Ben, what is it?
You do 20 minus 11
Perfect.
is 9. So that's going to be your first number.
Yep.
And then 20 plus 11, you get 31, and that'll be the next one.
Perfect. Exactly right. Ben showed me the difference. He showed me the sum. He knew exactly what order to put them in. Perfect. Good job, Ben. All right, somebody else I haven't talked to, help me with number 3.
I can.
Okay, Maggie, what do you think?
I did 23 minus 14,
Okay.
which equals 9. So that would be the first number. And then I did, for the sum, 23 plus 14, which is 37, which would be the second number.
Perfect. Very good. Same thing. Difference, sum. We put it in the right order. We have our inequality. Perfect. Great job, guys. Okay. I'm actually going to throw you in the pool without any floaties, and I want you to try the next problem. There's a couple different ways you can do it. I want you to think, if I know that 2 of my sides are 9 and 2, do these work? So I want you to take a second. Your answer for all of these should just be yes or no. So yes or no for all of these, using this concept from above, from all the way up at the top. Think about that for a minute, and then I'm going to need help. All right, take another minute to finish. All right. Again, I'm looking for someone I haven't talked to yet. Two sides of a
I
triangle.
can help you.
Awesome, Megan. Two sides of a triangle are 9 and 2. Can the third side be 7?
No.
Why not?
Because when you do the 9 minus 2 and 9 plus 2, the number has to be in between 7 and 11, and it's not including 7, so you can't have 7.
Perfect. So Megan knew that if she did her sum and difference, that shortcut we just talked about, that anything that is okay has to be between 7 and 11, but cannot be 7 and 11. So she did a lot of work on the front end, but now she's able to just say, oh, does it fit or does it not? And 7 doesn't. Good job, Megan. What about 8? Can 8 work?
Yes.
Yes.
Yes. Yes, it does fit into Megan's range, right? So that works. What about the next one? Does 10 work?
Yes.
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 Yes. What about 11? Does 11 work?
No.
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 No, hard no is coming from you guys. This one doesn't work because it's not less than 11. It's actually 11. It's not less than. That doesn't work. And then what about 14? Is that okay or no?
Absolutely
No.
not.
No. Hard no. No way. Not even close, right? So what you could have done is if you didn't think what Megan did, that's totally fine. You can just simply do, okay, is 2 plus 9, or I guess the other way, we do 2 plus 7. Is that greater than 9? Is 2 plus 8 greater than 9? At the end of the day, as we're checking it, you want the two smaller sides to be bigger than the biggest side. So you can do these all where you adjust so that you're checking so that the biggest side is on the right side and the two smallest sides add to be greater. But it's really easy to do the sum and the difference and then just see does it fit or not. So both ways are correct, either the orange or the pink. You don't have to do both. But this was just kind of a simple understanding application of what we've just learned. So good job, guys. That's the end of the notes today. So your homework is the next side. Again, we're going to do a little bit more practice together. So I'm going to pull up those homework problems for us to practice for like the last 9-10 minutes of class. But remember, this second sheet is homework. Do whatever you need to do in order to make sure you know this is homework. So we're going to jump to Schoology. I posted this earlier today, so maybe you saw it, maybe you didn't. Again, this was the textbook problems that you were supposed to do last night, but I didn't post, so I didn't ask you to do them. However, I do think they're still important. So they're labeled Geo 5.1 homework blank, which is a terrible label. I know, I'm so sorry. It's not more straightforward, but that's just what I labeled it for whatever reason. And so I want you to download this into Notability because I want to do some of these together. So let's do that. Let's jump over here.
The ones that we don't get done, do we do it for homework?
Great question, Amanda. You do not have to. So since I messed up, you don't need to do this at all for points. This is just extra practice now. So we're just kind of throwing it into class, and you are welcome to use this to practice on your own, but you will not have to turn these in. All right, let me erase a couple things from last period. What I want you to do is start by looking at number 24, because we're going to run through that quickly. And then we're going to look at number 30, because that is like the last problem from our notes and like the last problem from our homework. And I think that's what we'll need the most practice with. So look at 24 right now. All right, 24. Anybody, what do we call this segment?
Mid segment,
Why?
because it makes the two sides congruent and it has two midpoints.
That's what I want. I want the midpoints. The important part is my midpoints. And so because I have midpoints, and Ava knows we have midpoints because those two sides are congruent and these two are congruent. And when you connect two midpoints, it becomes a mid segment. All right. I know we learned two things about mid segments yesterday. Somebody new, tell me one. What's one thing we learned about mid segments? Let me specify a little bit. Mid segments compared to the side opposite.
The mid segment is half of the side.
Very good. That's what I'm looking for. So mid segment is half of the third side. I know this is not very nicely written, but it's as good mathematically as we're going to get. All right. So Gwenna told me it's half the third side. And then what's the second piece of information we learned yesterday?
It's parallel.
Parallel. Good. That's what I'm looking for. If you could not immediately think of those two things, you got to study yesterday's notes, because this is the bare minimum of what we learned yesterday. So these two concepts are super important. Okay, I'm going to use the one that Gwen had told me, though, to write an equation to solve for x. So someone I haven't talked to on this paper yet, can you help me write an equation?
I can.
Awesome, Maggie. Help me out.
5x minus 4 equals 2, and then 8 in parentheses.
So Maggie took what Gwenna wrote over here with the mid segments, but she didn't want to play with the fractions, so she multiplied 2 on both sides. So that's why the third side is all by itself and that the mid segment is multiplied by 2. Totally great way to write it. And now we don't even have any fractions. We don't have to move anything around. We're just going to multiply and solve. So the left side stays the same, and I get 2 times 8, which is 16. Add your 4. 5x equals 20, and x equals 4. Perfect. That's all I wanted to do on this problem. I guarantee on the quiz you take next week, there will be at least one or more problems like this. So if you could not do that, we got to figure out how to get you to do that. Questions, comments, concerns? Awesome. Okay, we're going to jump down to number 30. And we're not going to get through all of it, but I'm going to get through as much as I can in the last 6 minutes. This is like the last one on your notes and the last one on your homework. It asks for midpoint, it asks for slope because they're parallel, and this is distance right here. I believe distance is the hardest one for us, but we do need to find the midpoints in order to do distance. So we're going to do that really quickly. We're going to find our midpoint. And I'm just whiting out this triangle over here so I can use this space to do my work. If you don't remember the equations for midpoint and stuff like that, that's okay. I was probably going to tell you this next week, but I can tell you now. With the quiz, I know since we don't have a final, you're not here in person, there's so many other things I need you to know. I'll put these formulas on the quiz this time. That does not mean that if we do it again, I will give it to you. I don't remember if we do distance or midpoint again, so you may be asked to know them at a separate time. But for this one, I will put them on there. You just need to know how to use them. All right, so midpoint is this formula, and we need to use, to find the midpoint of, that's H, that's the midpoint of EG. So I'm going to use 1, 2, and 3, -2. We do our average of our x's plus the average of the y's. So H, my laptop's being weird. That's okay. So the x's are 1 and 3, and my y's are 2 and -2. 1 plus 3, 2 and -2. Oh, let me be consistent. Okay, so 1 plus 3 is going to be 4 over 2, and then 2 plus -2 is 0 over 2. So I get 2 comma 0. Oh, nice easy numbers, perfect. Now I have to find J, which is the midpoint of FG. So now I'm using F and G to find J. So F is, or the X's are 5 and 3. And my Y's are 6 and -2. Oh no, that's not what I wanted at all. Okay, that dot's just gonna be there, I guess. All right, now I'm gonna simplify. 5 plus 3 is 8 over 2, and then 6 plus -2 is 4 over 2, which again will give me a nice pretty number of 4 comma 2, perfect. Okay, again, I didn't think midpoint is your guys' weakness. If it is hard for you, this isn't a dig, I just don't think it's usually one that we struggle with. But I needed to do that in order to do distance now. So now I'm going to do distance, which is letter C, show that HJ is equal to 1/2 of EF. Remember, distance formula is x2 minus x1 squared. Today's not the day. Plus y2 minus y1 squared. And I need to find the distance that's HJ and the distance that's EF. So HJ is, oh, that's that point over there. I don't know why I scrolled away. 2, 0, and 4, 2. So I'm going to do 4 minus 2 squared plus 2 minus 0 squared. 4 minus 2 is 2. 2 minus 0 is 2. So I'm going to do 2 squared plus 2 squared. So I've got 4 plus 4. Nope. Yep. Which is 8. And then don't forget to factor tree. 8 is 4 and 2, and 4 is 2 and 2. So my 2's get to come out. 2 radical 2. That's my distance. Next, we would do 1/2 of EF. And EF are these 2 points, 1, 2, and 5, 6. Five minus 1, 6 minus 2. Five minus 1 is 4, 4 squared. 6 minus 2 is also 4. 4 squared is 16, and 16 plus 16 is 32. Now we got a factor tree, 4 and 8. 4 becomes 2 and 2, and 8 becomes 2 and 4. 4 becomes 2 and 2. I don't remember if we as a class had a question on this or if it was a different class, but remember when you have 2 things to take out, we multiply it when we take it out. So 2 2's that come out becomes 2 times 2, which will be 4. And then the 2 that doesn't have a friend stays on the inside. We have to do 1/2 of that to see if it equals 2 root 2. So 1/2 of 4 radical 2. 4 divided by 2 is 2, so I get 2 root 2. Oh, perfect. That equals what I want. I know I kind of speed rounded this at the end, but it's really important that you know how to do it, so I did another one. If you want more problems like this, I'll do my best to find some more and send them to you guys, but this is going to be on a quiz, so you need to know how to do this. Again, I'm not here to play games. I'm not here to, trick you. I just want you to know how to do it. So if you need help, let me know. Any questions on what you see? Okay, I'm gonna stop my share. I'm gonna stop my record.